DCC Day, we've done quite a few now. We were in New York and then recently in Austin for Consensus and now here in Singapore, all around the world. It's such an important movement and I'm so happy to be here on behalf of Secret and Silent Swaps. So it's going to be an awesome discussion, one of the biggest catchphrases in crypto now, but I'm glad we get to break it down, make it more tangible and explain just exactly why DePIN is so important today. So that'll be my panel and I'd like to introduce my panelists without further ado. We've got Amir Bedi, the CEO of Tashi. Welcome. Alex Zaidelson, CEO of SCRT Labs. Welcome. And Anil Murty, VC of Engineering at Akash. All right. So let's get this conversation underway. I'm really excited to get started now. I'm actually going to stand here so I can see you guys. So the title of this panel is The Importance of DePIN, like I was saying, and we're going to break that down because as DeFi focuses on finance and DAOs focus on governance, DePIN is about decentralized infrastructure. So I'm excited to have this conversation with people who are kind of on the cutting edge of this movement. So I'd like to actually get started by allowing my panelists to introduce themselves, and then we'll get right into discussion.
Hi, everyone. My name is Amar. I'm the CEO of Tashi Protocol. Tashi is a decentralized cloud primarily for gaming. Our focus is that we want to enable decentralized gaming. We've been building this for the last 18 months. Our core tech that we've built is a consensus engine where we brought consensus to finality time under 30 to 50 milliseconds. That allows us to put the compute back onto the player's hardware and take away the cost that you have on the cloud.
Thank you.
My name is Alex. I'm CEO of SCRT Labs, a developer of SCRT Network. SCRT Network is a layer 1 confidential computing chain. We're not doing DePIN per se, but I'm very interested in the area, and I published like sort of an overview research showing how most, if not of the existing DePIN protocols kind of suffer from leaking private information, and I'm here to discuss this particular aspect. But in general, I think DePIN is a fascinating thing where we, as a Web3 industry, kind of sponsor or pay people to deploy infrastructure which otherwise would be next to impossible to deploy at such a large scale.
Thank you.
Hey everybody, my name is Anil Murty and I lead the product and engineering team at Overclock Labs. Overclock Labs is the core contributor and the creator of Akash Network. And Akash Network, if you're not familiar with it, is the world's first super cloud. We launched our mainnet about 5 years ago, initially with pure compute, storage, and memory. And then we have added accelerated compute to our platform about a year and a half ago. So what this means is that we're the first full service equivalent of AWS running on a blockchain now. What Akash does is it basically provides you all sorts of compute, whether it's regular compute or accelerated compute, to run anything from a static website all the way up to AI training. So for example, some of the people using Akash today include services like Venice.ai, which is basically an open version of ChatGPT that runs on Akash. There's another company called Brev.dev that is basically built a platform for fine-tuning various AI models that runs on Akash, and in fact, it's now part of NVIDIA. So technically, NVIDIA is a customer of Akash now. So Akash is what makes Akash really unique in this whole space, given there's so many DePIN projects around now, is that we're one of the first projects to build this kind of a service, and we're still the only project that is truly open source and has real demand and workloads running on it.
Wow, thank you. It's an honor to have a real powerhouse panel that can kind of like take us a little bit deeper into this subject matter, a very important matter at that. Actually, one of my main focuses in this industry, having been here for so long, is the bridge between these two worlds, the traditional financial world and the crypto world. And I know that in order to get this real adoption, true scaling, we need this kind of infrastructure. We need this kind of tech to enable that. I now, as a Zebu governance member, they just made a partnership with Silent Swap, and I think it's integral part in bridging those two and allowing those transactions to happen seamlessly and with the privacy and the data control. And so I think that's really special. And when we start this panel off now, speaking of bridging the gap, what role does DePIN play in bridging that gap between decentralized digital and physical infrastructure? And why is its convergence so critical critical for the Web3 world?
So I'm happy to go first. I think the number one reason DePIN exists today is that there's an underutilization of GPUs and CPUs, right? So if you look at, there is a massive demand for GPUs, which obviously there's a shortage of. And even on the CPU side, you have all these high-end data centers. But if you look at the actual utilization, it's 60% for CPUs. For GPUs, like you have all your Apple M1s, M2s, M3s, which have GPUs, but those aren't utilized, right? So you're going to the NVIDIAs of the world and saying, I need more. But for a lot of the use cases today, which is moving from, in the AI world, moving from training data to inference, you can run that on laptops that are lying at people's houses, right? So I think the first use case understanding is that DePIN is decentralized physical infrastructure, right? So there's physical infrastructure that exists outside of the centralized guys that can be, can enable multiple industries out there, right? I think the second part is, how does blockchain enable that, right? So I think there's two parts. So you don't always need blockchain for using those resources. So there's people who've been or offering those resources without having a blockchain element. So what blockchain does is it enables you to tokenize those assets and then enables the companies to pay for it in a seamless manner, right? So if you have one company like say Akash, which has millions of people contributing, the tokenization and payment via blockchain mechanism enables that scalability in a very seamless manner, right? And that is essentially what bridges the gap between Web 2 and Web 3, right? So for us, for example, we're in gaming. One of the big use cases we've seen is there's recently a case happening in Europe where there's a bunch of large gaming studios and publishers that have shut down very popular multiplayer games. And the reason they've shut them down, because the number one cost they have is the infrastructure costs. And they can't make more revenue from these games, so they shut them down. What we're saying is that, hey, there's players who want to play these games. There's a massive petition going on. Can we move this overhead of infrastructure from the cloud that the company's paying back to the player's hardware device, which they're very happy to do. And so DePIN infrastructure actually enables that. So there's lots of real world use cases that DePIN is solving problems for. But I think the number one, I think, problem is the underutilization of resources.
Oh, yeah, interesting. Thank you for that. That was more of a deep dive. Yeah.
I like to address like another angle of DePIN, which is deployment of physical infrastructure that is not compute. And we're talking about cellular base stations, we're talking about weather stations, we're talking about smart cameras and stuff like this. And I'm talking about companies like Helium or Demo or WeatherXM, and there are a bunch of others who are actually deploying, well, this physical infrastructure, which is like not computers, not your laptops, not your servers, but just physical stuff, right? And what DePIN allows is what Web 2 mechanisms could not really sustain before. There were attempts, like there was a company called Fawn that attempted to deploy Wi-Fi infrastructure all over the world, but they couldn't pay for it, and the only incentive for somebody to get this accessible, this router accessible to everyone was like access to all the other routers in the world, but there was no monetary element to that because they were a startup, right? So Google, for instance, they can allow to pay drivers hundreds of dollars per day to drive around and make pictures, right? But we don't want Google to be monopoly in that. So that's why startups like, say, Demo or HiveMapper, they incentivize people with tokens to do this, and so does Helium and others. So this is a really fascinating thing that allows us as an industry to decentralize or demonopolize deployment of big infrastructures, which would not be possible without blockchain infrastructure and without tokenization. So all that said, this is all great, but the problem I'm kind of surfacing here is that today all those deployments of all those hardware elements are recorded usually on public blockchains, and that leaks privacy, leaks a lot of private information, like On some of those smart dash cam companies, your registration is on chain. So your car model and make, and maybe even some of your traveling, is available on chain. So if I know your wallet address, I could connect it to and know which car you're driving and when, which is probably not desirable. Or if you have like a Wi-Fi router that's part of a DePIN infrastructure, or a cellular transmitter that you're running, again, your location, your geographical location is being leaked. So that's why we at Secret are talking about using confidential layer 1 chains, confidential blockchains to record this information, to create like an end-to-end system where all of the user data is protected. So that's my take.
I think that's a really interesting take as well, and a great illustration of the difference and how, you know, the decentralization is happening versus the monopoly in the Web 2 world, and why that's possible. Because a lot of people just ask me, why blockchain? A lot of people from Web 2, they're like, what can you do that we can't? And that's been, you know, the overrising theme since I started this world tour years back. So I think that's a really interesting point, and also the fact that, you know, you don't want all your data available publicly. You wouldn't want your bank account available publicly and all your transactions. So there's definitely a need for privacy if we want to scale at any significant level in taking this movement to the next level. So those are really great points and very interesting. Yeah. So on that note, I think we can segue into the next question, which is on scalability and sustainability. How can DePIN models contribute to scalability and sustainability of blockchain networks, especially in resource-intensive industries? So kind of following on that thought. Shall we start with you?
Sure, I can take a stab at this. So let's see. So obviously, you know, Alex talked about a bunch of different types of DePIN networks, Wi-Fi networks, and all of that. You know, our primary expertise, at least in Akash, is around compute. That's what we do. That's our bread and butter. So I'll focus pretty much on that. So if you think about compute today, and sort of why DePIN matters in case of compute, and then talking about scalability and how you achieve that. Who here, just with a show of hands, thinks that blockchains are important for humanity? I would expect more hands, but that's pretty decent. And then who here believes that open source is the right way to build software? Okay, awesome. So if you believe in those two things, then you should believe in the power of decentralized compute networks, and this is why. I'll explain to you why. First, if you go to a website called ethernodes.org, you can check it out if you have your phone or something. This will show you a breakup of where all the various Ethereum nodes are hosted today, right? So if you go and look at the chart over there, what you'll see is that nearly 75 or 80% of the nodes that run Ethereum today are all running on 3 centrally hosted services. They run on AWS, they run on Hetzner Cloud, and they run on like Azure and Oracle, right? So basically, what we're saying is that you know, everybody believes in the power of blockchains. Ethereum is the biggest blockchain today, and everybody believes that that's the right way to go, and decentralization is important. But the ultimate infrastructure that's underneath it is controlled by these 4 companies. And if you think that there's no risk to that, think again, because Hetzner actually decided a year ago that they don't want to have to do anything with blockchains or crypto. So they can decide to just, you know, completely disable all the nodes, all the Ethereum nodes that are running on them, and you wouldn't have a blockchain anymore, right? So that's one reason for why you need infrastructure to be decentralized. And so what I mean by decentralized is that no single entity should control all the infrastructure that is used by various applications, and that needs to be controlled by more than one entity, so that if one person or one entity decides that they don't want to run your application, you still have other choices. And that's exactly what Akash essentially builds today. On the other side of this is the open source part of it. And so when you think about, you know, AI in the last couple of years, obviously one of the biggest players in that initially was OpenAI, and that's what, you know, caused sort of the AI revolution to get started in the last couple of years. And OpenAI, contrary to its name, is a very closed company. So they build models and they give them out to people through APIs, and no one has access to the code, no one understands what the code is doing, no one has access to the data. They just use the APIs and pay the company, right? And there's been a significant amount of companies that have built open equivalents of that, including Meta, most famously. And so if you want more of those kinds of open models to be successful, you need to provide a platform that is able to provide the compute necessary for that, right? So Now, if you think about the kind of compute you need to run these models, it's primarily GPUs today. And that's primarily produced by one single company, which is NVIDIA, right? So the challenge you face today is that if you, as a person that wants to build some sort of application as a startup, want to utilize one of these open source models, you're still very reliant on being able to get those GPUs. And the challenge today is that if you want to get one of those GPUs, it's really expensive to buy them outright. And so you end up going to a cloud service. And because the cloud services themselves are dependent on this one company called NVIDIA, they have sort of a shortage on their hand, right? So they pick and choose who they're going to give their compute to. So if you want to, for example, go and get a cluster of H100 GPUs from AWS, you have to commit to buying, 64 of these for one full year, or you won't get access to them. And so that's where Akash comes in again, and we're able to provide those kinds of, platforms and chips to people, ranging from, 1% to 10% companies or anything else of that sort. So then the question now becomes, how do you scale this kind of an operation, right? So the way you do that is by separating out the control plane from the data plane. And so you touched upon this a little bit, Alex, which is how do you preserve privacy? So you're taking Secret obviously takes the privacy preserving aspect of this. What we care about more is just pure scalability of the solution. And so what we do is we use the blockchain purely on the control plane. So basically we use the blockchain purely as a coordination mechanism to match demand with supply. And then once the demand and supply match is done, all the user data gets stored only on the providers of compute. And so one common thing that people get wrong about Akash is that they tend to think that the nodes on Akash are doing both validation as well as providing compute. But the reality is that there are two separate kind of nodes. There are nodes that do validation of blockchain transactions, and then there are separate nodes that provide compute. And so all the user data gets stored off chain, but all the control plane information is available on chain, and that's what's used for coordination. And that's basically how we're going to achieve scalability with this. We are pretty confident about being able to achieve like really large scale clusters and do training and stuff like that over time.
Wow, that's really interesting. And, I'd done research on Akash before, but it's interesting to hear you clarify how the inner workings are. And an overlying narrative here is the democratization of that GPU, right? Of those GPUs and making that open and decentralized in this movement, and that Secret is essential for. Also because, as you said, you're concerned with scalability, but what happens to the privacy aspect? It feels like one can't happen without the other in a serious way. So really interesting to hear of those correlations and the way that it works. I don't know if you guys wanted to add something to that?
Yeah, I think you essentially had said two things. One was scalability and sustainability. So I think he answered scalability. I don't have anything to add to that. I think on sustainability, what I'd add is that these data centers they require massive natural resources to keep them cool, right? So what people don't realize is that when you have all these data centers that AWS and all these other large companies are running, they have massive cooling systems that require massive lakes around them that keep these data centers running. And that comes at a large cost to the climate, right? So people talk about mining related stuff, but and this is regular compute that is used for daily stuff, right? So I think that's where DePIN actually comes in, is that you have all this compute lying around in people's homes, right? All these gaming hardware and other hardware that people have that can be utilized globally. So if we essentially run those, it reduces the pressure that you would have on all these data centers that people are focused on. So as a company, what's happening or used to happen is, hey, I need something that I can spin up quickly, right? And you would naturally think of AWS or Azure or GCP and just straight go there. As we're getting more and more large DePIN companies like Akash, and we're building our own DePIN network, what happens is, and we're building a solution that's similar to what AWS offers, people will stop going to those guys because our cost is firstly lower, and two, people over a period of time will understand and appreciate that this has a much more sustainable angle to the environment as well.
Yeah, it's really interesting to hear how it diverges from the big players and how it's kind of like integrated now into blockchain and how it's changing. Because a lot of the players who do get those GPUs, they sell back to them as well, the big players. So it's kind of like, how do we democratize this process? So it feels like you're playing a part in that.
Yeah, and if I can add one more thing, I forgot about the sustainability aspect of this, and thanks for bringing that up, Amar. So one of the things that we have been finding in Akash is that if you think about, GPT-2 and Meta's previous model, Meta Llama 1 or Llama 2, there was a bunch of GPU clusters that were used to train these models, right? So, for example, GPT-2, OpenAI GPT-2, was trained on a large cluster of NVIDIA V100, V as in vertical 100 GPUs. And when they went on to train, GPT-4o or the latest, model that came out a couple of days ago, they're now using H100s and maybe even GH200 clusters for these, right? So what happens to all that old compute? It goes somewhere because they have a limited amount of data center space. They have to replace those GPUs with the next generation GPUs from NVIDIA in order to train these larger and larger models, right? So one of the things that we are doing is we're working with a company called Cato Digital, which has tie-ups with a lot of these big tech companies that goes and brings all that previous generation hardware onto Akash. And this is one way that we are driving sustainability by basically enabling people to use what was otherwise, used compute that was going to go waste, to basically use that for inference. So while you might need these really large and high performance computing clusters for training, in many cases you can use the previous generation hardware for inference.
Wow, amazing. I'm learning a lot just by listening to you guys on this panel. It's really interesting how this works on those deeper levels. And so on that note, I'd like to go into, as we are going into this movement, it's such a monumental change. What are the key challenges in implementing the DePIN in traditional industries, and how can they be overcome through innovation and policy?
So I want to talk about the data protection aspect of DePIN, right? So in decentralized compute network, when I'm sending some sort of a calculation or using an AI model to ask a question, so two things happen. First, my request is probably recorded on a blockchain, or at least my payment or some metadata of my activity is recorded on the blockchain. And then the operator of the machine normally would just get access to my data, right? So if I need to calculate something, then the guy sitting somewhere here in Singapore, say running their own GPU or whatever, if they wanted to, they could get access to all my data. And that kind of limits what a responsible person or discerning person would be willing to do on such a network, right? Because if I'm running LLM inference and I'm running like therapy model, let's say, I don't really want people whom I don't even know and I don't even know where they are to get all my requests about my personal problems. Or I don't even want people to know that I'm using a model like this, because in itself, this information is maybe something I don't want to share with the world, right? So I think, so this is a challenge, and now, thankfully, with the latest NVIDIA H100s that now have trusted execution environment, which is not super easy to set up, but some people have already done that, and we're also working on that at Secret. So an end-to-end encrypted system can be built where both the metadata and the data itself can be fully decentralized. And then if everything is protected by those trusted execution enclaves, as a user, I can feel confident sending even my very personal data to those models. And to me, this is like the next frontier of the DePIN computing, making everything confidential, making everything protected, so that people can run workloads that they're very confidential, but they are so that they are not afraid of sending it out there. Because we know even today a lot of big organizations don't want to send their data even to Google or to Azure, because they value their data, and they have to go and build their own in-house solutions just to protect the data. So with confidential computing across the board, this problem will be solved, and they will be able to use this decentralized infrastructure in a very efficient way.
Oh, that's huge. I mean, that's really big for other industries as well, coming into blockchain and utilizing that technology. I think that's really cool. Yep. Go ahead.
Yeah, fully. Everything Alex said is like 100% spot on. We're seeing that so we have a lot of clients in Europe, And all the gaming studios, one of the big challenges that they faced was with the advent of GDPR being like implemented, that these companies now need to store all the players' data, and it actually gets stored on a cloud. So they don't have, so the option becomes, do they set up a data center of their own where they have to manage it, which is really costly. So they trust the cloud guys. So it's like a liability on their books, which they don't have control over, right? So that's one problem that blockchain is really trying to solve right now, is you can get all the data that you need and use zero knowledge proofs where, for example, one of the use cases is ad related data, right? So a game needs to serve an ad to a player, and they need to know the player is of a certain age. That's why they can see that ad, right? So the original way would be to collect that data, store it, and manage it, right? Which creates the risk. Now, because you have zero knowledge proofs, which is confidential computing in a way, you decide who gets to see that ad without having to store that player's data. And that has been a massive change. And I think the problem was, I think in the last few years, as this technology is improving, it was really costly to run zero knowledge proofs. But that cost has been coming down. And with DePIN networks, it also allows the game studios to store that data across a whole bunch of places, right? So you don't have to use zero knowledge proofs and still go back to the cloud, right? So this kind of combination is really opening up confidential computing at scale, where all the different industries can get confidential data and store it across.
Yeah, I mean, that's big, just to be able to pick and choose the data that you need. You don't need to know everything about a person in order to ascertain the data that is necessary for them to transact with you. So this is one of the biggest uses of blockchain, in my opinion. So as we wrap this up, then the last question: how can DCC enhance data privacy and security in physical infrastructure, and what are the potential risks involved? So you kind of touched on that. What would be the risks then involving that?
So I think one of the risks that I guess like a big part of the theme this year in blockchain we see is chain abstraction, right? Which is, how do you have interoperability in a certain way? I think right now, because you have every chain essentially focusing on their own data, one of the big reasons this hasn't become so mass or so at scale is that you're kind of segregated within ecosystems, right? And I think that interoperability is going to be a big hurdle that blockchain will be crossing in the coming years, that you'll have data, you'll have your liquidity that is cross-chain without having risks, right? So I think every chain understands that now. They're all building the bridges, they're all building the tech that enables that. But I think that's probably one of the biggest barriers that we'll see overcome in the next 2 to 3 years.
Because the bridges are inherently quite risky, right?
Exactly. So I think having those bridges without the failure risk, or like having them as the single point that people attack, that's going to be the biggest hurdle to cross.
So then you ask, like, what are the risks, or what are in the combination between DePIN and DCC, or like, what is the future? So first, I think that this combination is inevitable, right? DCC is inevitable in all of Web3 eventually, and it is and will be coming more and more to DePIN, again, because the bigger are the use cases and the bigger is the audience, the more people are conscious about the need to protect the data. Now, the risks are in technology. Does it work? Do those TEEs work across the board? Or is the ZK performant enough? Or is the FHE performant enough? But eventually this will be solved by a combination of different tools. So I think it's less of a risk, it's more of a lot of hard work that we will all need to put into this. But I think in 2-3 years from now, we'll see that more and more of DePIN infrastructures support data protection on a certain level, and that a lot of them support like end-to-end data protection on all levels, and that will make DePIN applications a stronger competitor to the centralized players.
Absolutely. I truly believe so. It's really exciting times. On that note, let's go over just closing thoughts about what you're most excited for in this DePIN movement, what you're building, what people can look forward to.
So I think DePIN, for the right reasons, is a big theme in this cycle, right? So it's not just a buzzword. I think there's a lot of projects that are building real-world use cases in DePIN, everything from all the projects that Alex was talking about in the beginning about wireless to mapping. We're focused on the gaming side of things. So we'll have a node sale that goes live, and our infrastructure is very different than a lot of the other node sales where the nodes actually help run a decentralized gaming ecosystem. So what we're trying to build is the example that's said in the beginning, enable decentralized games to run where you don't need infrastructure from the game studios and game publishers. So that brings down your centralized compute cost by 50 to 70% from using a cloud. That's kind of what our core focus is. And we'll have a token coming up end of the year. So exciting times.
All right, thank you.
Well, I'm excited about the rekindled interest in TEs across the board, and specifically in NVIDIA and Intel and AMD continuing to invest a lot in TEs, making confidential computing scalable, cheap. Yes, there are certain risks. Yes, we have to trust NVIDIA, Intel, AMD, and Amazon, but as we see it, it's worth it. And this technology will allow data protection with very little performance degradation, and it will work across a lot of different industries and a lot of different use cases.
Oh, it's massive. I'm super excited to watch this play out, especially now that the technology is ready, right? It's ready to be implemented. Exactly. It's been a long time coming, and it's very exciting to see where it's headed. So what's next for Akash as we close this panel?
Yeah, I think when I think about something that's exciting for any new project that you think, so if you think a project or a new technology is disruptive, meaning it's going to challenge the status quo, then I feel like there are two inflection points. The first is making sure that you meet the users of that product or service where they are today, meaning if somebody's using a centralized service today, provide the same kind of user experience on the decentralized side. And then second, after that, is provide value that they cannot get on the centralized service. So with those two primitives in mind, I think the two things that I'm most excited about for Akash is, number one, in the next few months, we are going to have a user experience that's going to basically give people the same exact experience that they'll have using any sort of centralized service, whether that be AWS or be, platform as a service similar to Vercel or Netlify or any of these other web hosting tools that you may have used. And what I mean by that is not having to ever know about the fact that there's a blockchain running underneath, never know about the fact that there's a token, never know about the fact that there are wallets involved, none of that. So it look exactly the same as that. So that's number one. The second part of it is how do you once you achieve parity, how do you sort of go to the next level, which is superiority? And on that, I see sort of two things. One is I talked about open source and how enabling and making sure that open source thrives is very important for the future of software and for the future of humanity in some ways. And so once we achieve parity, the next thing we'll do is we'll work on using crypto incentives, aka magic internet money, to make it such that people who produce open source software are able to actually monetize it and not have some big company like AWS just steal their open source software and offer it as a service and make money off of it, like AWS has done in the past. So those are the two things I'm most excited about.
I love how you broke that down. Magic internet money to monetize. Yeah, that's what it's all about. That's what blockchain enables. I think you guys very clearly and eloquently broke it down about why this movement is so important, all the different elements, scalability, sustainability, incentivization for people to break away from this monopoly model that we have in the Web 2 world, and also the importance of privacy. So guys, it's been amazing to host this panel today, and I encourage you all to go up to them, meet them, ask some questions afterwards, and thank you.